Hey guys, today we are going to talk about proving triangles similar by side-side-side similarity and side-angle-side similarity. Yesterday we talked about angle-angle similarity, so we'll now have three different ways to prove that triangles are similar. So we have side-side-side similarity theorem that says that if corresponding side lengths of two triangles are proportional, then the triangles are similar. Okay? So if AB is to RS as AC is to RT as BC is to ST, then triangle ABC is similar to triangle RST. So if all three ratios of sides would simplify to exactly the same fraction, then the two triangles are similar. So let's see if either of these two triangles are similar to triangle ABC. Okay, so we'll start with the shortest side, which is 8. Okay, and put that over the shortest side of triangle DEF, which is 4. Okay, now that needs to be exactly the same as, let's use the longest side, 12 over 8. And then the remaining sides are 9 and 6. Okay, now those simplify to 2 over 1, and then 3 over 2 and 3 over 2, and one of those isn't the same as the others. So triangle DEF is not similar to triangle ABC. So how about triangle GHI? Is it similar to triangle ABC? So we'll start with the shortest again. 8 is to 16 as, let's go with the longest, 12 is to 24 as, and then the remaining sides, 9 is to 18. 8 over 16 simplifies to 1/2. 12 over 24 is 1/2. And 9 over 18 is 1/2. All three ratios simplified to exactly the same thing. That means the sides are proportional. So triangle ABC is similar to triangle GHJ. Okay, are there any similar triangles here? Okay, let's just start with these first two. Okay, shortest over shortest, 38 over 30. Okay, longest, 54 over 45. And then the remaining sides are 42 and 35. Okay, so do those all simplify the same? So we can use a calculator if we want to. So let's do that. So let's do 38 over 30, and that is 19/15. Okay, 54 over 45 is 6/5. Those are not the same. So what is this one? 42 over 35 is 6/5. Okay, so this 19/15 is not the same. So we would have to say that these two triangles are not similar. Let's try the first and the third. So we'll go with the shortest, 38 over 18. The longest, 54 over 27. And then the remaining sides are 42 over 21. Okay, so we've got 38 over 18. That is 19 over 9. Okay, 54 over 27 is 2 over 1. Not the same. 42 over 21, 2 over 1. So that 19/9 doesn't match. So the first and last are not similar. How about the second one and the third one? So we'll go with the shortest sides, 30/18. The longest are 45 and 27. And the remaining sides are 35 and 21. So do those all simplify the same? 30/18 is 5/3. 45/27 is 5/3. And 35/21 is 5/3. Okay, so it's these last two triangles here that are similar to each other. So we could say triangle PQR is similar to triangle. Now let's try to get that in corresponding order. So PQR, so from P to R, that's the longest side. From P to Q, that's the longest side. And it goes from the medium side to the shorter side. So here's the longest side from medium to shortest is ZX. And so that would be ZXY. So those two triangles are similar to each other. So now we want to find the value of x that makes triangle ABC similar to triangle DEF. So we'll start with x/3 or x minus 3. So x minus 3 is to something over here. So that's on side AB. And AB corresponds with DE, which is 20. Okay. And then I've got a couple options. I could go with 4 from BC is to EF, 10. I could go with 4 is to 10. Or I could go with 10 is to 2x plus 3. Now, if I can stay away from having variables in both of the sides of this proportion, I'm going to stay away from that. So I think it would be simpler if we go with 4/10. Now, if we do 10 over 2x plus 3, it's possible to do that. It just gets us into a much bigger problem, more complicated. Part of me actually kind of wants to do that, but a larger part of me says, no, let's just keep this simple. So we'll cross multiply. And when I cross multiply, I will distribute. So I'm going to get 10x minus 30 equals, and then 20 times 4 is 80. Okay, so I add that 30, and I get 10x equals 110, and then I divide both sides by 10, and I get x equals 11. Okay, so now find AB, the length of segment AB, so that ABC and QRP are similar triangles. Okay, so AB corresponds with QR. So the first two letters here, first two letters here. So QR, that's 30. And then I just need another pair of numbers. So how about BC at 42? Okay, so BC, the last two letters, goes with RP, which is 35. Okay, so I get 35 times segment AB equals 30 times 42, which is, that's not right, 30 times 42, 1,260. And I can divide by 35 and find the length of segment AB is 36. Okay, then we have the the side angle side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, and the length of the sides including these angles are proportional, then the triangles are similar. Okay, so if angle X is congruent to angle M, and the sides including them, so that means these sides, okay, that has that angle between them, are proportional with these sides that have that angle between them. So that means XZ over MP is the same as XY over MN. Then the two triangles will be similar to each other. Okay, so in this bird feeder design, the top and bottom triangles, will they be similar? Okay, so with the information we are given, will this triangle here be similar to this triangle down here? Okay, so here's what we are given. We have an angle here that's 87 degrees, and down here, 87 degrees. Okay, now the sides that correspond, we have a 32 and a 20, so 32 is to 20 as 32 is to 20. Okay, I don't even need to know what they are simplified because I can already see they're exactly the same ratio. Okay, so I know that they will simplify the same. So I have an angle here, and the sides that include that angle are proportional. So yes, they are similar. So write a similarity statement. Triangle ABC is similar to triangle DEF by side angle side similarity. Okay, so here's my similarity statement and the reason that they are similar. Now, what if the top and bottom triangles were equilateral triangles? Then would they be similar? And the answer is yes, they would definitely be similar, because if they're equilateral, so let's just make up some equilateral triangles. Let's say the top triangle is 8, 8, and 8, and the bottom triangle is 3, 3, and 3. Then my ratios of sides would be 8 is to 3 as 8 is to 3 as 8 is to 3. Okay, so those are all the same ratio. Okay, so they would be similar by side, side, side similarity. Okay, now these are equilateral, which means they are 60, 60, 60. All three of these angles are 60, all three of these angles are 60. Well, if at least two angles from here are the same as two from here, that means I could use angle-angle similarity. And I could use side angle side, because I've got these two 8s, these two 3s, so 8 is to 3 as 8 is to 3. The included angle is the same. So I could use side angle side similarity. So any one of those reasons would tell me that two equilateral triangles are always similar to each other. Okay, so is there enough information to determine that these are similar triangles? If so, give a similarity statement and a reason that they are similar. Now they have vertical angles right here, so these are the same. So if the sides around these two angles are proportional, then I know that these will be similar triangles. Okay, so I could try 9 is to 24 and 18 is to 12. Okay, so do those simplify the same? I don't think so, because 18 over 12 is bigger than 1. 9 over 24 is not. So they're not proportional in that way, but let's try this. 9 is to 12 as 18 is to 24. Okay, so 9 over 12, and 3 goes into both of those, 3 times and 4. 18 over 24, 6 goes into both of those, 3 times and 4. So if I look at it this way, and this way, then those sides are proportional and the included angles are congruent. So yes, these are similar. So the similarity statement, triangle PQR is similar to triangle, and the triangles are turned backwards with each other, so it's going to be TSR. And that is by side angle side similarity. So there's my similarity statement, and there's my reason why they are similar. Is there enough information here to show triangle JKL is similar to triangle LKM? Okay, so to find out, we are going to take the shortest side of JKL, which is 28, over the shortest side of LKM, which is 16, and set that equal to the longest ratio, 56, over 32. And then the remaining side, over here I have not used 49, and here I have not used 28. Okay, so let's see if those all simplify the same. So we have 28 over 16, and that is 7/4. 56 over 32, 7/4. And 49 over 28, 7/4. Okay, so the ratios of sides are all the same, all three side ratios. So yes, they are similar. So yes, and that is by side, side, side similarity.